Hello, my name is Pratik De. So today we are doing the lab experiment of digital electronics. So in our experiment we are doing the experiment one by one. So in digital electronics lab, the first experiment is investigate the logic behavior of AND or NOT, NAND, NOR and XOR gate. Okay, so this is our first experiment of digital electronics lab. So as you all know very well that these are all logic gate, and you all needs to be familiar about the function of each and every gate, right? So and or not, these three gate are the basic gate, and NAND and NOR are the universal gate, and exclusive OR gate, this is the special gate. Okay, so at first you all have to remember the IC number of the following gate. I hope the screen is visible. Just I enlarge the screen so that it is seen very well. So you all have to remember the IC number of all the logic gate. So the OR gate IC number is 7432. You all remember. AND gate IC number is 7408. NOT gate IC number is 7404. NAND gate IC number is 7400. NOR gate IC number is 7402. XOR gate IC number is 7486, and to perform this experiment you needs the this components such as breadboard, resistor, battery, LED and connecting wire, right? So here in this table all the components you all are able to see. It can perform physically, that means you can perform this experiment by your own hand in physically, by seeing the all the components, but the same experiment you are able to perform by a simulation tools, by simulation software which name is Proteus. So this experiment can also be performed by simulation. So today we are going to look at to perform this experiment by a simulation software which name is Proteus, right? So before going to Proteus, we are look at the function of each and every gate. So this is the AND gate, right? And this is the logic gate in this IC. That means in one IC there are 4 gate is available, and you see the pin number of that IC. That is pin number 1 and 2 are the input and 3 is the output, and this is going on. 4, 5 are the input and 6 is the output. Now the pin number 7 is ground connection and pin number 14 is the positive supply, right? So this is the pin diagram of this logic gate IC, that is AND gate, right? So the same IC pattern is also for each and every gate. Now this is the truth table. You all are familiar about the function of AND gate. When both the inputs are 1, only on that situation the output is 1, and the remaining all cases the output is 0, right? So this is the truth table of AND gate, and the same thing today we are verify by this practical experiment, right? Now we are now doing this experiment of AND gate, right? So just see one by one. So now after installing this software Proteus, you are able to see the icon, that is Proteus 8 Professional. Okay, so you need to double click on that icon. So just see carefully. I double click this icon. Now when you double click this icon, this screen will comes up. In that screen you need to click on new project. So you click on new project. So when you click on new project, at that time you need to give a particular project name. So you can choose any name by your choice. Suppose you will give your own name or any name, just experiment 1, right? So just Right now I give any letter such as y. You give here any name of your choice, and after that you click on next, and you need to click on several times next. After that the last button is finish. You just click on finish. Okay, so when you click on finish, now that panel will comes up. This is the same circuit panel which you also do the same experiment by a breadboard. That means you can assume it as a breadboard. Now you need to place all the components here to perform this experiment, right? So at first you here I just you see that here you see that which components is required. You see that is the corresponding gate. After that the register, battery, LED and connecting wire, right? So the same things I am writing in a notepad, you are able to see. So the first component is switch. So you just see the first component is switch. I just copy it. Now when this Proteus will comes up, after that you just watch this button. So click on component mode, and after that click on component. After clicking the component mode, you need to click on P icon. Just you see I click the P icon. Okay, so when you click the P icon, the search box will appear. In that search box you need to type the appropriate component name or model number. So just my first component is switch, right? So just I copy just few moments before, just you see I paste it. So switch. Now do one thing. When you click on switch, there are several kinds of switch will appear. Now among this list you need to choose the particular type. So this is the our required switch, that is this one. No, not this one. SPDT. Our required switch is SPDT. Matlab that means single pole double throw, right? So you just choose this one, single pole double throw. This is double pole double throw AJ. Now here you see this one, single pole double throw. This is called SPDT. That means single pole double throw, right? So I choose this switch. Now click on OK. Okay, so this is the first component of our experiment. So just I place this component here, you see. So you need to click 2 times. In your first click you just able to see the component in anywhere. Now when you click the second click, when you do the second click, that component is placed on your required position. That means suppose I want to place this component here, so I need to do second click. Okay, so you click on second times. Now when you click second times, the component is attached on this breadboard. You assume this panel, this blue color border panel is as a breadboard, right? You assume it. So here we place all the components one by one. So now when you place this component, you just do a little zoom so that it will appear in your screen. Now just as your position, you just place it. Now you just do little more zoom. Okay, so this is clearly visible when you click on zoom. Now this icon, this position, you choose how you want to see on the screen, right? Just do the click so that it will free. Now this is the first switch. Now for why we place the switch, you will see later. So now I just move the switch position. in a mirror like this one. Now the we need to place another switch. That means here this switch are the inputs, such as you see here. That means in a logic gate, you see, suppose this is a logic gate, right? So this A and B are the input and Y is the output, which can perform the corresponding operation. That means for AND gate, as we all know, AND gate performs the multiplication. That means A dot B multiplication. So here Y is the output and AB are the inputs. So we need to do the same thing. That means these two inputs are here is replaced by a switch, right? So we need to click on second switch, just place it, and again you need to move the position. You need to change the position, right? So I change the position. Okay, now the switch is done. Now you need to give the second component, which is a power supply. That means DC power supply. Now one component is DC power supply, another component is ground, right? So click on this terminal mode. You need to click on the below icon, that is terminal mode. When you click on terminal mode, at that time you will find the power. So at first you need to place here the power. So I just place the power here. Okay, after that you need to place the ground. So click the ground component, place the ground component, right? Actually this is what, this is the positive and this is the negative, right? In any DC supply, the positive part is this and the negative part is this ground, right? So now after that you need to take the IC, required IC. Now as you all see that we need to verify the first AND gate, after that OR gate, after that NOT gate. So these are the IC number of this several gate. So I just do the same experiment. So at first we are starting OR gate. So OR gate IC number is 7432, right? So after that you again click on component mode and click on P button. So here you need to type the IC number. So that means our first logic gate is OR gate, so 7432. You need to remember this IC number. So just I type 7432. You see, when I click 7432, the corresponding OR gate will appear. So you just click on OK. Otherwise you can just double click on it. Okay, and after double click, you just close it. So this component comes up in this panel list. So just click this IC, click this logic gate anywhere of your record position. Suppose I want to place this component here. Okay, so I just place it here. Now you need to take the another component, which is register. You see, as you see here, that here a register of 220 ohm. You see the value 220 ohm, right? So I need to click here the register. Another component is register. So here you can type the register. So I just copy it from this notepad. You can do any one, either you can type or you can copy or paste. So when you click on register, there are also several list of register will comes up. Now you need to choose the generic register. You see here, I choose the generic register. So click either you can double click or you can make OK. You may click OK or you just double click. So I just double click. After double click, close it. Now you need to place this register here. You see, I just place it here, right? Okay, now you need to take the output y, that is, you can you can take one LED as the output, right? So just choose the another component, that is LED, right? Now you see, I can copy it, LED, and just paste it. So when you click on LED, there are several types of LED will comes up. Now you need to choose the required LED which you want. Now suppose I want to take this one. This is what? This is a animated bicolor LED, blue and yellow with self flashing, right? I choose this one, blue and yellow. Uh, there are also many more color are there. This is a green. This is a you choose any one. Suppose I choose this first one, LED, this one, yellow color, right? You just double click on it, it will comes on the panel. So just click a LED here, you see here. So now all the components we are arranging. Now we need to connect each and every component by a wire, right? So here you are able to see the cursor. Now as you connect a particular component to another component, there you all will able to see a red color dot. So this is the symptom to connect the parts. Okay, now I connect this power button. That means this is the positive and this is the negative, right? This is the power means positive and this is the ground means negative. So I just connect all these things. So just you see, I in which way I can connect, you all will do the same thing. So I connect at switch 1. Okay, just now I rename it. So I just rename it, edit level, then I replace it by A, that means input A, right? You see, I just rename it A, and switch 2 is replaced by B. I just type here B, or you can do anything XY like that. So I just type here B. You see, I type here B, right? Then click on OK. So this is our second input B. Now I can rename this LED as a Y. That means this is our output, right? So I just type here Y. I just type here Y. That means A, B and Y. So here A, B are the input and Y is the output, right? Now you all watch carefully how I connect all these parts. So the power means positive and ground means negative. I am telling again. So just connect the power, that means positive, to the A and B side. Okay. Now actually this switch function as a SPDT, that means single pole double throw. That means the upper part is 1 and the lower part is 0, right, in binary number system. That means if you want to take A as a 0, then you need to connect downwards, right? And if you want to set A as a 1, then you need to click on the upwards, right? That means when you want to set A as a 1, you need to click upwards. When you want to set A as a 0, you need to click downwards. And the same thing is applicable for B also, right? So do one thing. The 1 means what? 1 means signal is present. That's why I set the 1 for both these two input as a positive connection. Now 0 means what? 0 means negative. That means we need to connect this 2 0 to the ground. You see here, I connect this 20 to the ground. Okay, you see carefully, right? Now these A and B, that means the switch is connected to the pin number 1 and pin number 2, that means of this logic gate input, right? So this A is connected to 1 and B is connected to 2. Just you see, you need to connect it. Connect A to the 1 and B to the 2. That means pin 1 is the input A and pin 2 is the input B, right? Okay, now the output of this logic gate, that means this OR gate, is connected to the register. Now you need to change this register value. You just right click on this register symbol. Now click on edit properties. After that you change this resistance value to 220 ohm. That means you have no need to write any unit. That means by default it will take ohm value, that means 220. Click on OK. Okay, so it will take 220 ohm, right? Now the output of this resistor is connected to the LED anode side. That means it is what? Light emitting diode. This is anode, this is cathode, and the cathode needs to connect to the ground supply. Okay, so just click on this ground, right? Click on this ground. Now the circuit is completed in all respect, right? So this is 7432 means OR gate, right? You just change this name if you want. You change it to OR gate, right? OR gate, OR. This is our OR gate. Okay, now this is OR gate. Now the circuit is completed. Now you want to verify its truth table. You see the truth table of OR gate. You see here. Now this is the truth table. You need to now verify this truth table. That means you see, when A and B both are 0, output is 0. Now A is 0, B is 1, then again output is 0. Now A is 1, B is 0, output is 0. Now when A and B both are 1, output is 1, right? You just see here, this is for which gate? AND gate. Now we are doing now what? We are doing now OR gate. So you need to see the truth table of OR gate. You just see, this is the truth table of OR gate. Now you see, in case of OR gate, when the inputs are 0 0, output is 0. Now inputs are 0 1, output is 1. That means if any one input is 1, the output is 1, right? You need to see it by here. So now you can run the simulation. You see, to run the simulation, that means your circuit is completed in all respect. Now you want to run this. How you run? In the bottom side you click the play button, right? This is the run the simulation. You see on the bottom side it is displayed by run the simulation. You just click on it. That means you need to click the play button. So you see, now you see here both the A and B are 1, right? That means I said before that when you click the upwards, that means it is 1. When you click the downwards, it is 0. Now you see that this A and B both are 1, so output is 1. Now you see, when you click on A0, B1, again you see. So at first do one thing, do the truth table in such a way, 0 0, right? A and B both are 0, out LED is off. Now if any one input is high, output will become high. Now you see, so this is for 0 0. Now you need to set 0 1. That means A is 0, B is 1. You just click on upwards. You see, output is yellow, output is glowing. Output is glowing, that means output is 1. Now you set it 1 0. A is 1, B is 0. You see, A is 1, B is 0. Again the output is 1 also. Now you need to set A is 1, B is 1. You just see, A is 1, B is 1 again. So only when A is 0 and B is 0, output will become 0. Output is off. You see? So our experiment is successful, right? For the case of OR gate. Now you see, after fulfilling your experiment, you just click on the stop button. You see, this is the stop button. Stop the simulation, right? Now now we will verify the another gate. That is, where right now we performed the OR gate. Now we need to perform AND gate. You see, so this is AND gate. This symbol is AND gate, and as you all know, the number of the IC number of AND gate is 7408, right? You see here the IC number of AND gate is what? 7408, right? So we are doing the same thing for the case of AND gate. Just delete it. You just delete object, so OR gate will become deleted. Now you need to pick up 7408. You just type 7408. You see, AND gate will comes up. So just double click on it. 7408. Now just click this AND gate here. Now you just click the wire. You just connect the wire in 1 and 2. Just click. Okay, and the output of this AND gate is connected to the register. So the circuit become fulfilled. Now you need to run it. So at first you set the both A and B 0 0. Just you see, A is 0, B is 0. Okay, now you run the simulation. Click on run button. Now you see, as we all know that in case of an AND gate, when both the inputs are 1, only on that situation output is 1, and the same thing you here verify. Just to see, A and B both are 0 0, so the output is off, output is 0. Now we set A 0, B 1. Just click on the upwards. You see, again the output is 0. That means LED is not glowing, right? Now I set A is 1, B is 0. Just see, B is A is set to 1 and B is set to 0. That means 1 0. Again you see, our LED is off. Now when you set both A and B 1, only on that situation, only on that circumstances, the output is 1. So the truth table of AND gate is verified. You see, this is the truth table. This is the truth table. You see, only on that situation, that means 1 1, the output is 1. You just verify it, right? You see, when A is 1, B is 1, only on that situation output is 1. So verification of AND gate is successful. Okay, just stop the simulation. Now we are doing the NOT gate. You see, NOT gate. You see, this is the NOT gate, right? So the IC number of NOT gate is 7404. You see, 7404. So this is the NOT gate. In NOT gate there is single input and single output, right? So whatever the input is going, the inversion of this input comes out. So that means if we are giving 0 input, output will be 1. We are giving 1 input, output will be 0, right? The same thing we are performing now. So 74, which is the IC number? 7404. Just delete this and get. You need to delete. Now just type again 7404, right? 7404. You see, when you click this NOT gate will comes up, right? So just double click on it. Okay, double click. So just take this NOT gate here. You see, now the second input is not required, so you need not connect the second input. You just connect only one input. Okay, and the output is connected to the R1, that means register. Now you see, now I run the simulation, right? So when I enter 1, output is 0. Now you see LED, we run the simulation. You see, now when I click the A as a 0, when I set A as a 0, then only output will become 1. You see, you just see, when A is 0, only in that situation output is 1. Now again we are doing this. A is 0, A is 1, output is 0. Now when A is 0, only on that Y is 1, right? So verification of NOT gate is also successful, right? So click on stop simulation. Now we need to verify the another gate. You see, so the another gate is NAND gate. So the IC number of NAND gate is 7400. Now at first you see the truth table of NAND gate. The NAND gate is just opposite of the AND gate. That means in AND gate, what we seen that in a AND gate, when both the inputs are 1, only on that situation output is 1. But in NAND gate, when both the inputs are 1, only on that situation output will become 0. And remaining all the cases, the output will become 1, right? That means it is just the opposite of AND gate, right? In NAND gate, NAND gate is the just opposite of AND gate, right? So just we verify it right now. So just delete this NOT gate, and you need to take the IC of NAND gate. So 7400, right? 7400. You see the symbol of NAND gates is, you are able to see. So just click on it, click on the OK button, double click. Okay, now you need to connect A and B to the NAND gate. You just see, I connect NAND gate, and the output of NAND gate is connected to the register. So the circuit is successful, circuit is completed. Now you need to verify this truth table, right? You need to verify this truth table. You see, for the case of 00, output is 1. For the case of 01, output is 1. For the case of 10, output is again 1. Now for the case of 11, the only output is 0. We are just verify this thing. So at first we are setting 00. That means A0, B0. You see, output will glowing. You see, we run the simulation. Just see, output is glowing. That means output Y is 1. Now we set 00. After that, after 00, we set 01. So 01, again the output is 1. Now we set 10, 10, again the output is 1. So now 11, output is 0. Okay, so you see, for the case of 11, only on that case output is 0. You see, so when I set A1, B1, only on that situation output is 0. All the remaining case, the output is 1. You see, all the remaining case output is, you see, output is, all the remaining case output is 1, right? So the verification of NAND gate is also successful. Click on stop simulation. Okay, so verification of NAND gate is also successful. Now we are doing the another logic gate, that is NOR gate, right? The IC number of NOR gate is 7402. So you see the truth table. The truth table of NOR gate, it is just the opposite of OR gate. That means in OR gate, what you have seen, you have seen that in OR gate, if any one input is 1, output is 1. Now here that is the same thing. If in a OR gate, what you have seen, that when both the inputs are 0, only on that situation output is in a OR gate. That means in a OR gate, what you will see, in a OR gate, for the case of 00, output is 0, and all the remaining case output is 1. This is the OR gate. Now in NOR gate, it is just the opposite. Okay, you all know very well. So you just see 7402. I just delete this object, and we need to pick up 7402. So this is the NOR gate, right? This is the NOR gate. So click on OK, or click or double click it. Okay, connect the A to the this pin and B to the input pin, this pin, right? And output pin is connected to the register. Okay, so circuit is completed. Now you need to run it. So just see. Now you see, it is just the reverse operation of OR gate. That means what? You see here. So we need to verify the truth table. For the case of 0 0, that means in a NOR gate is just reverse of OR gate. Output is 0. Now when you set sorry, this is the case of 1 1, right? This is the case of 1 1. Now you see, this is the case of 0 0. You see, for the case of 0 0, output is 1. Now for the case of 0 1, right, 0 1, output is 0. For the case of 1 and 0, you see, for the case of 1 0, output is again 0. Now for the case of 1 and 1, you see, output is again 0. That means only when the inputs are 0 and 0, only on that situation output will become 1. You see, so the truth table of NOR gate is verified, right? You see, only when A and B both are 0, actually it is the truth table of OR gate. It is just in the lab manual, it is just wrong. So you all just see here, as I say, that means in a NOR gate, when A and B both are 0, only on that situation the output will become 1. All the remaining cases output will become 0. You see, when I set A is 1, B 1, again the output is 0. Now A is 0 but B is 1, again output is 0. Okay, so only when you set A, B both 0, only on that situation output will become 1. So the verification of NOR gate is also successful, right? Now stop simulation. Now we need to do the another. After NOR gate there is XOR gate. You see, this is the XOR gate, IC number 7486. Now you see the truth table. So in case of XOR gate, only when the inputs are different, only on that situation output will become 1. That means when the inputs are same, output will become 0. You see, for the case of 0 0, output is 0. For the case of 1 1, output is 0. But when the inputs are different, that means when the inputs are 0 1 or 1 0, output will become 1. Now the same thing we verify here in the simulation tools. So just delete the previous gate. Now you need to pick up the XOR gate. So what is the IC number? 7486. You need to remember this, 7486. Okay, so you are able to see this is the symbol of XOR gate. Click on OK. Okay, click on OK. Otherwise you will just double click it. Okay, so instead of click on OK, if you double click, it will again comes up. So just you see, just you need to connect input A to the pin 1 and input B to the pin 2, right? And output pin 3 need to connect to the register. So the circuit is successful. When the circuit is completed, now you need to run. Just click on Sorry, there is a error. uh, any problem? This is XOR gate. Okay, I play it. Which one? What happened? Okay, I just save it and close it for the moment. Okay, I just reopen it. So just double click on it, Proteus. Okay, you just open this project. You can pick up the same project. You see here I saved it by this name, right? By this name. So just choose it, click on open. Okay, so just zoom it. Okay, now you see the things. The circuit is completed. Okay, run it. What happened? Okay, so you need to take the component of XOR gate in 7486, right? So you all know 7486. So in this list you need to choose this one, 74HC86, right? That means when you click this one, but you, instead of this one, you need to click this one, right? This is, you need to choose this one. Okay, just double click on it. Just double click on it. Okay, you see 74HC86. Just click on this icon. Just this XOR gate. Just connect this one and connect B to pin number 2, and the output 3 pin is connected to the register. So the circuit is completed. Now you need to run the simulation. So click on run. Now you see, in case of XOR gate, when both the inputs are different, only on that situation output will become 1. Now you see here, A is 0, B is 0, output is 0, right? Now when A is 1, B is 0, output is 1. Now when you set A1, B1, again output is 0. Now when you set A1, B0, output is 1. So for the case of A0, B0, output is again 0, and for the case of A1, B1, output is again 0. Now when you set the AB different, that means when you set A0, B1, output is 1. Now you set A1, B0, output is 1. So the verification of XOR gate is successful, right? So click the stop simulation. Now you need to verify the last gate, that is okay, you verify all gate, right? So the verification of all gate is successful. So thank you so much. So in this way you are performing this experiment 1 by Proteus. So thank you for watching. Have a nice day.